Today topic is for different Mohr circle for different cases. For first of all, life stresses. What is life stresses? Suppose this is a body, sigma x, this is sigma y, means sigma x and sigma y both are same in nature. Same in nature. Same in nature means both are tensile in nature. This is tensile, this is tensile. For life stresses, Mohr circle. Now suppose this is plane A, coordinates. Suppose this coordinate have sigma tau, sigma x, and there is no shear stress, so 0, sigma x 0, and this is plane B, sigma y into 0. Here see, tau is 0, shear stress is 0. Now draw Mohr circle. First, already I said, first locate plane A, sigma n and tau plane. First sigma x 0, this is, suppose this is sigma x 0, sigma x comma 0, and plane B, this is plane B, sigma y, this is sigma y comma 0, plane A and plane B. Now draw Mohr circle. This is plane A, this is plane B, and when equal and like stress, when equal when both are equal in magnitude, then means like and equal stresses, equal and like stress, equal and like stresses. Both are, that time plane A sigma comma 0, suppose sigma x sigma y equal to sigma, then plane A, and plane B sigma comma 0, that time, and draw Mohr circle. Now plane A, sigma n tau, plane N, plane B, plane A first locate and plane B, both are same. We can say we can say for equal and like stresses, the Mohr circle reduced to zero. Mohr Mohr's Mohr circle reduces to zero. Means radius of Mohr circle 0 and infinite number of means it means radius of Mohr's circle is 0 and infinite number of plane infinite number of plane already says the circumference of Mohr circles have infinite number of planes and each have infinite number of points. Each point represents number of state of plane, stress of plane. Next, unlike stresses. Unlike stresses means this is body sigma x, suppose sigma x tensile in nature and sigma y is compressive in nature. Then we can say this is state of stress, and we can say this is unlike stresses. Now plane A sigma x comma 0 and plane B, this is plane B, assume plane B minus sigma y comma 0. Now draw Mohr circle for unlike stresses. Suppose plane B, this is plane A, and plane B sigma y means sigma y comma 0. This is plane B. Now draw Mohr circle. This is plane A and equal and unlike equal, and you can change the nature of the stresses. Suppose this is compressive, you can assume this is compressive, this is, and same plane A at negative and plane B at positive, sigma n and tau plane. Equal and unlike stresses. Plane A sigma comma 0 and plane B sigma x equal to sigma y equal to minus sigma. Then let's draw the Mohr circle. Draw the Mohr circle. Sigma comma 0 plane A. This is plane A, and this is plane B, and plane B and you can say the center of Mohr circle, the center at the origin, center of Mohr circle at sigma n and tau coordinate at origin of, this is O, origin of sigma n tau plane. In case of equal and unlike stresses, in case of hydrostatic pressure and liquid in a fluid are equal and like stresses. Okay, equal and like stresses. Suppose this is and liquid, and there is assume a point, and the pressure at a point is equal in all direction. Equal pressure. So draw state of stress. Suppose sigma and sigma, and plane A minus sigma comma 0 and plane B minus sigma comma 0. Draw Mohr circle. Sigma n and tau plane, and plane A sigma comma 0 and plane B, this is plane B sigma comma 0. So Mohr circle in case of hydrostatic pressure in liquid is reduced to 0 and infinite number of plane. Now Mohr circle for pure bending. First, for pure bend, we have for draw Mohr circle for pure bending. First we understood the bending. What is bending stress? First, when some point, note down some point, when a body, when a beam is subjected to bending moment, when a beam subjected to bending moments and subject to, this is hogging, this is sagging or concave, sagging, bending moment, when beam subjected to sagging and or concave, concave, and this is hogging or convex, and at beam. Initially the beam was straight, but when bonding moment is subjected, then is sagging. This position is sagging or concave, and this position is convex. You can say here the top fiber compressive and bottom fiber tensile, and here hogging, and this bending moment when sagging positive, sign convention for bending moment positive, and this is negative for bending moment, sign convention for bending moment, sign convention for bending moment negative when hogging, and here this compressive, this is tensile, and in this case the at top fiber is tensile. You can easily understood because there is just try to elongate. So here tensile, and here compressive, and the internal molecule of the beam provide resistance against this against tension at the upper convention. When initially the beam was straight, and when bending moment, beam is subjected to bending moment, this is sagging, and this is hogging, and sign convention for bending moment in case of sagging is positive, and sign convention for bending moment in case of hogging is negative. First, when beam is subjected to bending moments and body is hogging, and at the top fiber tension, and the bottom fiber is compression, and the internal molecule of the beams at the top fiber provide resistance offer against tension, and at the and top fiber at bottom fiber internal molecules of the beams provide resistance offer against compression, and there will induce a indirect stresses is called bending stresses. That's why it bends, and the bending stress normal to the cross section of the beam. This is cross section of the beam, and this is indirect stresses. And here consider a element A and at bottom fiber element B, and for element A and for element B the Mohr circle is here. Element A, this is element A, and here is tensile in nature, the bending stress tensile, and now this is plane A, plane B. For plane A, tensile sigma bt, 0 and plane B 0, 0, and draw Mohr circle. Tau and sigma n versus tau. First locate plane A, sigma bt, 0, this is and B 0, and draw Mohr circle. And for element B, compression, and the Mohr circle for element B, this for plane A, sigma bc, 0 and sigma b 0, 0. Understand? And you can easily draw Mohr circle sagging condition. Now Mohr circle for pure shear or pure torsion. Pure torsion or pure shear. What is torsion?